Leetcode. Today we will be solving a Leetcode weekly contest 430. So let's get started. So first we will be solving problem number one. So in this, the problem name is a minimum operation to make a column strictly increasing. Okay. So in this we have given a matrix or grid of size m into n consisting of non-negative numbers. Okay. And in one operation you can increment the value of any grid, like any grid I of ij by 1. Okay, and we have to return the minimum number of options needed to make all the columns of the grid strictly increasing. So what does it mean, strictly increasing? So strictly increasing means like 1 2 3 4. Okay, increasing means 1 1 1 1, that is also increasing, but strictly increasing means there should be a difference of 1 at least. Okay, so as you can see in the example number 1. Okay, so we are having a 3 1 3 0. Okay, so as we have 3, so how much operation we need to make it strictly increasing? There if we are 3, then it should be 4. Okay, so we need 3 operation there. Now it is 4 and we are having a 3, then we need 2 more operation to make a 4 2. If we are having a 4 here, then we need to make it 5. Okay, and if we are making it 5, then we need to make it 6. Okay, it's so if we are starting with 2, then it is 3, then it is 4, it is fine, but that one needs to be 5. Okay, so what we can do is we will be taking a previous. Okay, so it will be for every row, like the 0th row and the jth column. Okay, now we will be checking, like if grid of ij is lesser than or equals to previous, then our previous minus grid of ij plus 1 is our operation. Okay, like we are at 1. Okay, and previous is 3, so how much operation do we need? We need 3 minus 1 plus 1, which is 3 operation we need to make it 4. Okay, so here it is 3 and we need to make it 4, then we need 3 operation. Okay, so previous minus grid of ij plus 1, and now our previous will become previous plus 1, so our previous will become 3 plus 1, which is 4. Okay, and else if it is the condition satisfies, like the previous is 3 and we are at 4, then we don't need to do any operation, the previous will upgrade it, will update to grid of ij. Okay, so that's it for this question. So let's move to next question. Okay, so the next question name is find the lexicographically largest string from the box 1. Okay, so in this we have given a string word and an integer num friends. Okay, so Alice is organizing game for her num friends, and there are multiple rounds in the game. Okay, so what we have to do is we just have to split the word. Okay, so let's suppose let's if you look into the example number 1, in this we have given a word dbca and num friends 2. Okay, so what we have to do is we have to split the word into two parts. Okay, so that means if we have given a word and we have given num friends, so we have to divide the word, like we have to split the word in num friends, and then we have to return the lexicographically largest. Okay, so what does it mean lexicographically largest? So a string A is lexicographically smaller than a string B if in first position where A and B differ, string A has a letter that appears earlier in the alphabet than the corresponding letter in B. Okay, so so we have to return lexicographically largest. Okay, so yeah, if we are having a DVCA, we have to split into two friends and return the maximum one. So how we can do that? So what could be the maximum length for a friend? It could be n minus num friends plus 1. Okay, so like if here we are having a length of 4 and num friends is 2. So what could be the maximum length? Okay, so it should be 4 minus 2 plus 1, which is 3. So for a particular friend, the maximum length could go up to 3. Okay, or we can say n minus num friends plus 1. Okay, So now what we can do is we will try every split. So for the I, we will be taking the length, so from I to I plus length, and we will be checking that if our current value is greater than the previous answer, then we are just upgrading the answer. But there are two edge cases. Let's suppose we are having only one friend, then we have to return full word because we can't split. Okay, so that is one edge case. And another is, let's suppose we are having a num friends as 2, and we are having a case as a triple n. Okay, so now if you look into the length, like 4 minus 2 plus 1, which is 3. Okay, that is a 3 is a fixed one. Okay, so you might return a AAN, you might return. Okay, because it is a 3 1, but the answer for this is n, because n is larger than AAN. So what we have to do is, so for the last one, okay, so it might be like the if we are splitting the word, and so for the last one we should try always. Okay, like we should try for 1, for 2, for 3, everything. Okay, so here we will be iterating to all the n's, and after that we have taken I plus ln. So in Python we don't have to write like in other language you can write minimum of I plus ln comma n, like minimum of I plus ln comma n. But in Python, if we are just providing I plus ln, then also it will be taking till the n. Okay, so that's how it is working. Okay, so let me just try to run this case as well. If we are having a 2, then it should return n. Okay, so that's it for this question. Let's move to the third one. Okay, so the question name is count spatial subsequences. Okay, so in this we have given an array nums consisting of positive integers. A spatial subsequence is defined as a subsequence of length 4 represented by indices p, q, r, s, where p is lesser than q, is lesser than r, is lesser than s. This subsequence must satisfy the following conditions, which is nums of p into nums of r double equals to nums of q into nums of s. Okay, and there must be at least one element between each pair of indices. In other words, uh, so like q minus p, the difference should be greater than 1, and the q r minus q, the difference should be greater than 1, and s minus r, the difference should be greater than 1. Okay, and as a subsequence is a sequence derived from the array by deleting 0 or more elements without changing the order of remaining elements. Okay, so like a subsequence is like we can take any kind of elements. Okay, so like 1 3 3 1, that is also a subsequence. Okay, and we have to return the number of different spatial subsequences in nums. Okay, so now if you look clearly, we are given nums of p into nums of r equals to nums of q into nums of s. Okay, so what we can do is we can just try to modify the equation a bit. So as we know, nums p is lesser than q, is lesser than r, is lesser than s. So we will try to make a pair of p, q and rs. How we can do this? So here we are having a nums of p, and here we are having nums of q. So we can take, we can just divide it by nums of q. So we are having a nums of p divided by nums of q, and we can divide it by r. So nums of s is divided by nums of r. So the equation will becomes, so currently we are having a this equation. But after this it will becomes, okay, so we will try to find pairs of this. So what we can do is we can take a map. Okay, so for every r, okay, like we will be traversing from the back, we will be having a s, which is r plus 2 to n, because we need a gap for one at least. Okay, and s is greater than r. So we will be trying all the s for the given r, and then we will be storing it into the map. Okay, then we will try for q. Okay, q is r minus 2, and there should be a difference which is greater than 1 for q and p. Okay, so nums of q is nums of q divided by nums of p, and then we will be just getting it from the our map, answer plus equals to d of I and b. If it is exist, then we are just adding it into our answer. It is pretty standard question if you just observe the pair thing and the equation, how we can modify that. Okay, so that's it for this question. Let's move to the fourth and the hardest one for today's contest. So the problem name for the last question is count the number of arrays with k matching adjacent elements. Okay, in this we have given three integers n, m, and k, and a good array ARR of size n is defined as follows. So in a good array, each element in ARR is in increasing range from 1 to m. That means all the elements in the array should be from 1 to m only. Okay, there should not be an element which is lesser than 1 or greater than m. Okay, and exactly k indices I, where I is lesser than n and greater than or equals to 1, satisfy the condition ARR of I minus 1 is equals to ARR of I, and we have to run the number of good arrays that can be formed. Okay, and since the answer is can be very large, we just have to return it by mod 10 to the power 9 plus 7. Okay, so if you look into the example number 1, where n is 3, m is 2, and k is 1, so there are four good arrays. These are 1 1 2, 1 2 2, 2 1 1, 2 2 1. So here we are having k equals to 1, which is satisfied. Only one adjacent element, and here one additional element, here one, and here also one. Okay, now if you look the example number 2, okay, we need two same adjacent element. So here if you look, we are having the two same adjacent element. Here for 1 1 we are having a 1, for 2 2 we are having a 1. Okay, here we are having a triple 2, that means we are having a two adjacent elements. Okay, so the constant are n is 10 to the power 5 and m is also 10 to the power 5, and k is lesser than or equals to n minus 1. That makes the problem a bit harder. If the constraint are 10 to the power 3 or 10 to the power 3, then it can be easily solved using dp. Okay, because we can take n into k as dp and then we can solve it easily. But now we have given n and k which is 10 to the power 5. So we have to solve it in big of n thing. Okay, so for that what we can do is we will be using the help of combinatorics. Okay, so first we have taken the factorial and then we have taken the inverse. Okay, that is quite you can find how we can calculate the inverse of factorial in the CP algorithm website. Okay, after that we are just having a function of NCR, which is a n factorial n factorial into r factorial divided by n minus r factorial. Okay, after that how we can calculate that? So first we have to calculate NCR of n minus 1 comma k. Why n minus 1? Because we have to find out the adjacent elements. So this will be giving us number of ways to choose exactly k adjacent pairs from n minus 1. Okay, and why we are multiplying with m? Because we are using m minus 1 elements for k pairs, because we have to find out adjacent pairs. Okay, after that we are left with first element, and first element could be anything. And in the question we have given that the array in the range 1 to m. Okay, so it could be any element from 1 to m, so we are multiplying it by m. Okay, so we have filled n minus 1 elements with the k. After calculating the number of ways to exactly k adjacent pairs from n minus 1, we are left with n minus k minus 1 positions where we have to fill m minus 1 values. So how we can do that? We just have to do power of m minus 1 comma n minus k minus 1 by mode, and that will be filling the remaining positions. And after that we can just return val by mode. Okay, it is a bit harder part, but if you know the combinatorics so well enough, then you can easily solve it. Okay, that's it for this question. If you have any doubt in any of the question, please let me know in the comment section. I will try to resolve it. Thank you.